Anyway, welcome everyone. I don't know if you've noticed, I'm actually wearing a GDG t-shirt in your honor. Okay, so everyone from GDG here? Okay. So I'm wearing it in your honor. Okay. Okay, so welcome to this talk on functional programming with Kotlin. And someone recently said to me, you shouldn't have titled it like that. I said, what should I have titled it? They said, not functional programming in Kotlin, but something around functional programming. I said, okay. So what I did is I ignored their advice, and I keep calling it the same thing. How many of you here have been using Kotlin extensively? Okay, great. Right. So how many, is there anybody from the Kotlin team here? Okay, way at the back. Right. So if you have any questions over there, right? If they don't know the answer, on the 5th floor, there's the rest of the Kotlin team. So you can go and ask them. I'll wait for you until you come back, and then maybe you'll tell me the answer as well. Right, so what I would like to do is start with, normally when I do my talks, I start with like why we're doing something, right? And it's a good question, like why am I here where the Kotlin team is giving a talk on Kotlin? Because that's not, as if that wasn't stressful enough, I'm going to talk about monads as well. But I want to start with the idea of why functional programming, and I'll show you some code, okay? Now, one thing I have to tell you, and I'll tell you this at the very beginning, any code that you see on the screen, this is for demo purposes. I never put code like this in production, because I never put code in production. But if I did, it certainly wouldn't be something like this, okay? Now, take a look at that code, and as soon as you know what it does, raise your hands. And don't tell me, don't shout it, just raise your hands. Okay, you can put your hands down as you read them. Okay, right, so more or less, everyone on the same page? Okay, now take a look at that code, and as soon as you know what it does, raise your hands. Yeah. Okay, so by my timing, you raised your hands much faster on the second one than on the first one. If anybody thinks that that's not true, I don't care, because if it wasn't, then the whole point of this talk would be useless. And if you don't like that, if you don't accept that as a fact, then we'll just call it an alternative fact. So the idea behind here of why functional programming is essentially the idea that, you know, I am trying to, in a way, abstract things away to make things easier to understand, right? And if you take a look at this code over here, I have a while loop, I have some if statements, I have some assignments, I have a whole bunch of different moving parts that are doing different things. And when I'm reading this code, what happens is that I have to eventually end up trying to understand what is going on. And in order to do that, I need to start to keep mental images in my head of everything, right? I need to become essentially the computer and understand like what is happening on the for loop, where it's assigning values, where it's changing values, etc. Whereas if I take a look at this, there's no magic there. It's simply just functions. They're just higher order functions, and we'll quickly give a review of that in case you're not familiar with that syntax. So what I'm doing there is essentially using functions to abstract functionality away. But under the covers, that is essentially the same thing. Now, even if you're not familiar with Kotlin, even if you're not familiar with the syntax, you essentially know that group by does something which is group by a value, right? Because everybody knows that. And, you know, map, well, we might not know what map is, but we know that it's not, you know, it's mapping values, and we figure that out at some point. Normally, given that we're all developers, most of us, and I say that for me, given that we're all developers, what is the one thing that we're very, very good at when we're writing code? Okay, I usually ask questions so people don't fall asleep, right? Especially after all those pizzas that you ate. That's a lot of carbohydrates. You need to use your energy. What are we very good at as developers? Huh? Yeah, and sometimes too much, huh? Making bugs. Writing code. I was going to say we're very good at naming things, but that would be a lie, right? But if you were, again, if you take that as a fact that we generally are good at naming things and we write our functions with good names, then essentially, you know, people that read our functions understand what they're doing without having to dive into the actual function and implementation or read the comments. And you know, there's a very common, Kevlin Henney, he has a very good phrase. He says that, you know, people say that comments are very good often to explain what some code does. Right? That's why we use comments, to explain what the code does. And there's this misbelief that people that write bad code somehow know how to write good comments, which is kind of crazy, yeah? So, right, so given that, you know, the idea is to create a few abstractions and abstract this away to make code easier to understand. Now, can we do this with Kotlin? Like, can we do functional programming with Kotlin? Because by definition, if you go to Wikipedia, and I know because I actually wrote the thing, no, I'm joking. You can, it says Kotlin is an object-oriented programming with functional constructs, right? Now, what is a functional program? What is a functional language? Anybody can tell me what a functional language is? You see, that's the great thing about asking this question, because it depends who you ask, they give you different answers. If you ask this in a general crowd of people, many people would probably say Haskell. Haskell is the only functional programming language there is. If you ask it in a .NET environment, they'll tell you F#. Right? And you know, that language that even Microsoft doesn't support that one, which is, it's by Microsoft. So ironically, we give it better support than they do. So, you know, what is a functional programming? I kind of like the definition of Eric Meyer, who worked on C# and did all of the link queue stuff as well, which he says that, you know, any language that basically treats functions as a first-class citizen. Right? And to all practical purposes, Kotlin does do that, because if not, this would be a really bullshit talk, right? I mean, I'm here talking about Kotlin and it doesn't support it. So what is first class? Well, in Kotlin, we have a bunch of things that we can consider treating functions as first class. The first one is that you can have functions at a top level, which is kind of nice because you don't have to wrap your functions inside static classes. You have functions that are, you have higher order functions, which are functions that take functions and, or return functions. And these things, in a sense, allow you to work with functions in a way that you essentially treat them as primitive building blocks. Now, one of the other things that you have when you're talking about functional programming is immutability. Okay, immutability is the idea that I cannot change things. Why do I want immutability? Because the more I change things, the more I alter the value of things, the harder it is for me to, again, understand. So if I take a look at this function is changing things all the time. I need to now reason about multiple things, right? So what does Kotlin provide in terms of immutability? Well, it provides a few things. It doesn't provide everything that, you know, many functional languages would desire or force you. As we say in Kotlin, we do not enforce immutability, we encourage it. And how do you encourage immutability in Kotlin? Well, one of the things that you do is when you declare a variable, right, you don't see this in here because I've actually moved away from that, but if you use the default Kotlin code style settings, when you write var, it underlines your variable. And that is purposely done to annoy you. Seriously, that is the reason, right? I would go for the whole fluorescent green on a pink background, but they don't buy into it. So, you know, that is kind of encouraging you to do immutability, much like the collections. We provide like an immutable interface on top of the collections. Okay, anyway, I was going to do some live coding, and all I've done so far is talk. So I will try and do some live coding now, and I've got my book, so everything is great. Okay. So for those of you that are not familiar with Kotlin, we'll very simple, x int equals y, x plus y. Okay, that's the shortest way, essentially, that you can write a function in Kotlin. It's a single expression function, which essentially means that I can write the function as a single expression. pretty much anything you could write as a single expression. I mean, even if you have an if statement or a while or a when, you can treat it as an expression, therefore you can write it as a single expression function. In addition, taken that we've all got 4K monitors, we no longer have the 80 character limit in column width, so we can just write everything on a single line as well, which is even more beautiful. So that is a joke, by the way. Please don't just. Someone's like arguing with me on Twitter saying, "Are you really suggesting that we can now have 400 characters per line?" I need to end my tweets with sarcasm all the time. So that is the smallest way to basically write a function. Okay, and one of the things that you want to aim for when you're doing functional programming, again, is going back to the whole aspect of immutability, is that you want to try and stay away from side effects. Okay, so side effects essentially means anything that mutates state outside of that function call. So when I call this function doesn't have any side effects, right? It doesn't mutate any state. I mean, it has the side effect that it returns a value, but it's not affecting anything around it, right? If inside there I was creating an object and then, or instantiating a global object or modifying a variable of a value of a variable global object, then what that would mean is that it's causing side effects. Why is side effects bad? Because then when we look at the function, this function says sum, and if this function is doing something else in addition to sum, we don't know what that other thing is. And then when we test this, we don't have idempotency, right? We know that if I call this once, it might have a result on a side effect. If I call it twice, it might have a different result. So we try and stay away from functions that have side effects. And we aim towards what are called pure functions, functions that do not have any kind of side effect. Okay? This is good because for many reasons, including testability. When I want to test a function, I know that anything around it, it's not going to change. All I have to do is test for the input, and given the input, I get the same output. Right? There's another aspect in terms of functions as well, which is total and partial functions, which we'll cover in a moment. Right? But there are pure functions is the idea that my function does not have side effect. We always try and aim for that. Okay, so to create a higher order function in Kotlin, you just write higher order. Well, you don't actually write higher order. I mean, I'm writing higher order. And then you pass in the function. And also there's something very, very cool, which is probably the coolest thing you'll learn today, is that if you want to be really, really cool, you don't write f here, right? So this is, for example, int, and then returns an int, okay? So that's a higher order function. That is a function that takes a function, and the alternative is a function that returns a function. This function, if you're not familiar, everyone familiar with the syntax here, right? It's a function that takes two integers and returns an integer. I've called this f. If you want to be really cool, what you do is you put alt f and then expand it, and you get a beautiful lambda, right? That is cool. And I bet you that the one question that someone will have is, how did you get the lambda? Right? Because it's actually, oh my God, I don't actually have this enabled. Shame on me, enable font ligatures. That was a question that I gave a webinar recently on Kotlin, right? And one of the guys that I admire the most, which is Eric Meyer, he was my moderator. So I was giving this webinar on Kotlin, which is already difficult giving a webinar on Kotlin. I mean, giving any webinar, because you're staring into a computer, not to a very lively crowd like yourselves, Yeah, okay. So I'm talking to this computer, and 50 minutes in, I keep like, are there any questions? Any question? Nothing, silence. 50 minutes in, out of the 1 hour webinar, Eric Meyer says, oh, Hadi, we have a question. I'm like, yes, finally, a question. I'm like, what is it? Yes, someone is asking how you get that arrow, right? So, it's like I've been talking for an hour on Kotlin, and they're worried about how they get this arrow symbol in IntelliJ. So my goal is that when I grow up, I actually want to be a developer. So this is how you declare a higher order function, and then what I can do is basically, just invoke that, and, well, invoke it with a number of parameters, and do whatever with it, okay? So single expression functions, higher order functions, right? And that's what we're going to use quite a bit. Now, we can also declare lambdas, like anonymous functions, although I say anonymous functions because in Kotlin there is a difference between a lambda and anonymous functions, which we'll see a little bit later on. But we'll be using lambda, so I can say, for instance, here, if I want to call this higher order function, I can just pass in x, y equals x plus y, right? And there's my lambda. And then I get the little squiggly here because it says to me move lambda outside of parentheses, and it says lambda argument should be moved out. Actually, that's not a should, it really should be a could. Could be moved out. So there you go. That's the different way that you write the lambdas in Kotlin, and you normally see that we can do something like that, which is beautiful, right? You know why? Because it looks really awesome when you do demos. But I'll also show you when we cover a little bit of a different topic, slightly related to functions, which is DSL, where that comes in useful. By the way, am I speaking too fast or I'm going okay? Okay, great, thank you. Right, so coming back to one thing that I just mentioned, which is immutability, and just a couple of things that we have regarding the immutability in Kotlin, okay? So the basics is var means mutable. That means that when I assign a value, I can change the value. You try and stay away from vars. You try to avoid them as much as you can. Val means immutable. That means when I write the value, I can no longer change it. So if I do this assignment like this, I can no longer change that value, which is what you want to try and stay with. When it comes to properties, we can do the same thing. So if I have a val, right, that is immutable. Okay? To all practical effects, that's an immutable property. However, this is not an immutable property. Okay? Because it is changing over time, right? So how do I declare a immutable property that is changing over time? It is not. You can't, because while I can't assign a new value to this, it is still not immutable. And one thing that you use in Kotlin is the const, and the const basically says that this value has to be expressed at compiled. It basically, whatever the expression is, has to be resolved to a literal, okay? But just because you have a val doesn't imply that you have immutability in terms of the property itself, okay? In terms of collections, well, collections, as you know, as I said, that I didn't. So I have val numbers equals 1 to 100, and I have val customers equals list of customer 1 and 2. Do I actually have a customer that's named Joe Smith? Do I have that? Do I have that? Yes, I do. See, that's why, no, I don't. Yes, I do. Import the customer, no, go away. We did not see that IntelliJ bug just now. Val name equals string. Val surname equals string, okay? So list of anything that you have, list of, set of, all of these are immutable in Kotlin. That is what you should be using. You should not be using mutable list of, which is why we make it longer. It should actually be renamed to mutable list of. Are you really sure you want to use this? Please press tab now. That would be nice. So all of these things are essentially immutable collections, which is, again, what you're trying to move to. Okay? So now that we've got that, let's move on to some things. Okay. Now, let's write some code. So I can say, for example, get some page. I'll say get some page, val, URL is string, and this is potentially going to bring back a string. And I say if URL is not empty, you don't do that. Is not, what am I doing? Is not empty, then return contents, okay? Else, throw exception, blah, right? Now, how many of you write code like this? Don't be shy. Like what? Like, there are so many things wrong with this code. You're like, what exactly are you meaning here? So one of the things that we try and do, well, one of the things that people often do is use exceptions for error handling, right? Which you try and stay away from. A much better approach to doing things like that is to do, I can return an object, right? I can say, for example, I can create a class called result, and then I'll say class result, and then I'll do val value string, and then val boolean, right? And then that should be yes. And then I'll say, well, if it's a return contents, then it's contents, and this will be false, right? Or I can initialize this to false. And if it's a true, this would be result. And if it's true, I would say, you know, result empty, and then this is true, right? No? Oh, return. Okay, so I normally name it E because I was a JavaScript developer, so we kind of name things with single parameters, so you don't know if it's event or error, but it doesn't matter. In JavaScript, it actually doesn't matter because they don't handle errors. They just think everything's an event, and I'm not insulting any specific JavaScript developer. I'm insulting them collectively. No, I'm joking. So, by the way, this is you can lift this to treat it as an expression. Okay, so. Now, the problem with this is what? Well, the problem with this is that, you know, if I have multiple values, I do not know when it is applicable to do one thing or the other, right? I do not know when that case is actually valid, that value actually contains a value, and E, whether it means an error or whatever, because if I have, for example, another property here, which is val code, which is, for instance, an int, I don't know if code is referring to the case when it is valid or when it is not valid. So, we used to do these. Don't do this, just return standard int, and then you can figure out the error code by lookup table. That's a joke as well. So what you try and do is you move towards what could be called, you know, returning different types of results, right? So I can say, for example, success here, and that has the contents, for instance, of type string, and then that inherits result. Well, in this case, it inherits result, and then I have class failure, that returns, for example, a code, okay? And then now what I can do is say result success, and just return the value, and result failure, and just return the value, okay? And if I could spell, it would be even better, right? So this would be success, okay? So now this has to be open, okay? Since it has to be open, what is wrong with you now?
The hierarchy is not implemented.
Oh, okay. So thank you. You are awake. You see, I'm doing this on purpose. So now the problem is that if this is open, if I come, for example, to live functions over here, and I do some, for instance, you know, class, sometimes in Spain, things don't work, which is ideal for a class name like that, and then inherit from result, that also works as well. Right? And the problem is that, well, first of all, I don't know about it, but anyone can inherit from that result. And what you want to do is, instead of doing open, of course, you want to do sealed, right? Sealed was essentially what it's doing is defining, it's closing the hierarchy of that, and it's saying that essentially these are the return, these are the types that you can inherit from result. And this doesn't even need to be a nested class, right? This can be external over here, right? And I can just get rid of the result, okay, and have the same thing. Now, the good thing is that I can now define another class that inherits from result, but it has to stay in the context of this file. So I cannot go to another file over here, for instance, and define this, because it says you cannot, right? It doesn't allow you to. So it's good because it gives you the locality of knowing exactly the result types that are available. Now, this is a much better way to do error handling or return multiple results from a function. Right? Because essentially it is covering the different cases of where I have a success or a failure. It is cheaper, of course, than throwing an exception as well. So in all practical aspects, it is good. What is the downside of this? Anybody? Nobody. There is no downside. Zero downside, right? Okay. So there is one downside to it, which is you're going to end up writing a bit of boilerplate code. Now, it's not technically boilerplate code because depending on the function, depending on the classes, etc., you are going to return different things. So it's not entirely boilerplate code, but it is the same pattern over and over again. So this is where some things like arrow come in, and what arrow allows you to, what arrow provides you. Any of you heard of arrow? Okay, so if you haven't heard of arrow, this is arrow. It's a functional programming library that the web page actually makes my CPU spin faster than IntelliJ compiling. And what it does is, this is if you're old to Kotlin, or you've known Kotlin for some time, we used to have a library called Functional with a K, because back in the old days, oh no, now still people replace every C with a K. And then we also had another library which was called category with a K. And then what happened is that like functional and category started to offer multiple things that were very, very similar. So the people behind category talked to the people behind functionality and functional, and they said, why don't we just like join and provide one unique experience to the Kotlin community, right? Which is basically merge the two libraries into one. Because both of the main authors came from another community, which I'm not going to mention, starts with an S, ends with an A. And there, one of the issues that they encountered was that there was too many choices for people, right? There was multiple choices. And choice is nice, but also people often want to know how the best way or an idiomatic way or a good way of doing something is. So they did this, and they provide a bunch of things on top of Kotlin. Now, disclaimer, given that not only I keep saying this, like I work at JetBrains, but it doesn't mean that JetBrains is endorsing this or promoting it or recommending it or anything like that. Now I'm in JetBrains doing it, that doesn't mean anything either. And one thing that I'm not entirely happy with is the functional companion to Kotlin standard library, because it feels kind of like this is the official thing. It is not, right? This is just the library of some people that are very enthusiastic, or some people in the community that are doing things. As we'll see more things around this, you will kind of maybe think that this is looking a little bit more like some other languages, which then you can judge for yourself, or, well, then what's the point, maybe? I don't know. That's for you to judge, not for me. So going back to what Arrow provides, one of the things that it provides is this thing over here, which is either. Okay? So the idea behind either is essentially what we just saw before, right? But in a more generic sense. So essentially what it's saying is that my class, my function can return a type called either. And that either is a generic type with two parameters, which can be either the left or the right. So instead of me having to write that result class and then from the result class write the success and the failure, I can say it either returns success or it either returns failure. And in this case, what I'm doing is saying, you know, if the country is not Spain, then either left, meaning that it is not applicable in Spain. If it is, the else branch, then return right. Okay? Now this gives me back the actual value. So I can say, for instance, get value Germany, and then, you know, I can say is left or is right. It can tell me whether it's a left or it's a right. That normally isn't that useful, because what you want to do here is you want to actually combine the value. You don't want to, like, I don't want to do an if statement that says if value is left, then do this, else do that. Because that again goes back to what? A lot of boilerplate code. Right? In this example over here, I have to do that as well, because when I call my main over here, if I say, you know, get page with some parameter, this is going to return a result, right? And then I'm going to have to say, okay, when are, and then, you know, is success, do something else, do something else. And that starts to become repetitive, especially if you start to combine this with other things. So one of the things that this library provides on top of this just is left and is right is the ability to start to operate on the result values. So for example, you have the fold, right? And the fold function essentially tells you what to do in case the value is left and what to do in case the value is right. Okay? So it gives you this data class that you don't have to repeat over and over again, and then it then provides you some operations, some member functions, which allow you to easily interop with the result. Okay, you're following me, no? Very, very simple. Now, let's take a segue a second, and I'm going to stop with the either. Well, actually I won't, because I'm going to say the valid. Now, the valid is like a more specialization of either. Okay, and in this case, basically it's saying that if a value is valid or not. So here, for instance, what I'm saying is I'm going to calculate a value, and I'm saying validated computation error int. So it can either give a computation error or it can give an int. If it is valid, then it's a valid result. It returns the actual result. If it is invalid, it will return an error. So this moves away from left and right to a more specialization of my function can return a result or an error. So now I leave the semantics of left and right, and I move to the semantics of valid, invalid. But essentially, it is the same thing. And much like we saw in the other example, here I also have the option of folding on these, right? So if I run this, in the first one, it's going to say that the result is a computation error, cannot divide by 0, where it is the actual data type that I'm passing in as the computation error. And if it is valid, then it's just going to return the result, right? And again, this I can start to chain and combine with other things. Now let's go to that segue, which is now no longer a segue, because this goes back to one of the things that we were seeing initially, right? If I go back to this function over here, okay, let's create another function which is called divide x int y int. And we'll say that that is, you know, x divided by y. We don't want to do that because we want to have some error checking. So we'll say if if y is greater than 0, then return x divided by y, else throw exception cannot divide by 0. Okay, now if I show you this function and I collapse it, is that function telling you the truth, or is it lying to you? Assuming that there is no out-of-range errors, is that function telling you the truth, or is it lying? It's lying. And that is what's called a partial function, in a sense, right? Because it is a function that is not actually executing for all input values, right? For 0, that function doesn't work, as opposed to a total function where for any input value, the result is always going to be calculated. So in this case, it's not working because until I don't drill down into this function, I don't know that it's actually throwing an exception. And that kind of becomes problematic. Yes? So how do you fix that? How do you, tell someone that is reading that function that this function may throw an exception? Checked exceptions. There you go. Yes, we go back to Java. So when you want to throw exceptions, use Java. That was a joke. That was a joke, yes. What you do is you can use this other data type that is provided in Arrow, which is called a try. Okay, so the try is very similar to before with the validated, etc. But in this case, what the try is saying is that this function can actually throw an exception. It's going to return a potential exception. So in this case, what I'm saying is that it can either return a string or it can throw an exception. Okay? Now, much like the other case, here, for example, if I run this, I say get or else. Well, what does get or else does? Well, as the name indicates, it does get. It gets something, or else it says not found. It executes the lambda. So what this is doing is it's swallowing, in a sense, the exception, and it's giving it back to you nicely wrapped in an object, right? Which I could then introspect and see the type of exception, etc. So not only is it saying that this function is now accurate to the signature, so in a sense, it is total because it is saying that it's always going to return a string or an exception, and you, based on the signature, you can tell. But it's also allowing you to move away from the exception, handle it in some way, and then continue the execution path, right? So this is an example of kind of like the either, but focused specifically around the case where you have the exception that is being thrown from your function. Okay, now let's take it up a notch and we go to options. Now you're all familiar with option? Who's familiar with option? Right, option is basically in Java and in Scala, like a value exists or value does not exist, okay? In Kotlin we have the built-in option, so to speak, which is like the Elvis operator, right? The safe operator to say whether, for example, a value is nullable or not, right? You use the safe operator and you say if it's nullable, then do something. If it's not nullable, no, if it's null, don't do something. If it's not null, then do something, right? So you have this, okay? Where's my main? Over here, I can say val A equals null, and then A length, for instance, or, well, A nothing, because it doesn't know what A is, a string. A length. And I have to declare it as nullable, okay? So this is basically like a built-in option that's part of the syntax that says, you know, if it's not null, do something with it. But that's just a generalization, that's a specialization of the whole concept of option, which is essentially saying if a value exists or if it does not exist. It may be that when the value does not exist, it's null. It may be that it's not null. It's some other constant or whatever we define. So arrow also provides you with this built-in, right? So you have option, and in this case I'm saying that the option could either return a string, or alternatively it can return empty, okay? So this is for places where you want to actually have a data type that can be of a value or a value not present. But again, much like the other examples of arrow, it is not limiting you to essentially only provide you with does it exist or does it not exist, is it left or is it right, is the ability to be able to build on this, right? So here, for instance, what I'm doing, I'm saying, you know, this is going to return an option. If it actually returns a value, I use just. Just means it's just going to return the value. Otherwise, I return empty. And then I come here with the normal way that we write code, which is when the result is none, then do something else, okay? But this is where, what happens if I start to want to combine these multiple options with each other? What happens if I want to feed one option into another option? So for instance, here I have a function called square it, right? That if it's 0, then return empty, else return just. The other one, if x equals 0, return empty, else return just. So what if I want to have a square it option that, you know, takes an option, and then if it is empty, it does something to it. It calls square it. If it is not empty, it calls it calls square it. If it is empty, it just returns empty. I have to continuously write these if everywhere, right? I constantly have to write these things. Well, you don't, because this is where things like map come in, right? So map basically is doing that if statement for you in a sense, right? It is saying, it is taking the option and is saying, I'm going to map that value, and I know how to behave when it is empty, and I know how to behave when it is not empty, right? Map is essentially, anyone heard of the concept of the term functor? Functor, F-U-N-C-T-O-R, right? Functor is essentially a type class. Type class is essentially kind of like an interface, and functor has a function called map, right? And the idea behind the functor is that it knows how to unwrap something, map, apply a function to that something, and then return it, right? So this is, if you look at the actual declaration of a functor, this is maybe, it was called an option, but essentially it is this. It knows how to behave. So it's essentially that code that we write over and over again, it is defined as part of the functor type class, right? So here I'm saying that fmap, it's called fmap really in functional terms, but you use map. So here I say if it's none, do this. If not, then just apply, return the just of applying the function to the inside value of that type that I'm passing in, of that option, or maybe that I'm passing in. So this allows me to cut down boilerplate code. It allows me to just say, okay, if it is option, if it's empty, don't do anything. If it is not, then do something, right? And then over and over again, I can basically apply these things, right? You see that now here, I'm actually taking an option. And I've cut down the amount of boilerplate code. I don't have to write this over and over again. And then, you know, much like before, we can do other things. Like all I've shown you right now is essentially the fold, but you have things like map. So if here I'm calling triplet option, I'm passing in the value 3, and then I'm getting the result, I'm mapping it, and then based on the map, I'm doing a get or else. In case there's an error, in case there's no value, it would return ABC. In case there is a value, it would return the value, right? There's also another function which is called flat map. And what flat map essentially does is it's very similar to map, but the return value is actually the type that you're passing in. So if I'm passing in an option, the return value is going to be an option. Okay? That's why here, when I'm doing a flat map, it's expecting that the last expression is the actual option that it's returning. Now, this then goes, yes? That's a very good question. So, if we were giving out T-shirts, I would give you a T-shirt.
Hadi, can you please repeat the question for the microphone, please?
Yeah. So the question is, does it ever make sense to use option over the built-in question mark nullability support that Kotlin has? If you are speaking specifically around nulls, right, whether a value exists if I want to be able to execute on it, generally no, if all you want to do is be able to execute. Right? If you want to do things like mapping and folding and all of these things, then of course it does make sense. Also, in the case where the non-presence of a value is not represented as null, then option will make sense, because option doesn't necessarily mean null. And potentially, you shy away also from the whole aspect of null reference exceptions with that. You end up in the try exceptions, empty exceptions. Okay. Now, one thing that I want to also show you, if you're familiar, before I go into the other one, which is the higher kinded types, there's another thing that, if you're familiar with data classes, how many of you use data classes? Okay, so data classes are, like I have, for example, a data class person, okay? And then I have, for example, let's say that I have a class, a class employee, okay? So employee, for example, inherits from person. Actually, does anybody know why that doesn't work? Why employee can't inherit from a person? No, because we all know that employees are resources and not people. No. I'm joking. And by the way, that is not what we think at JetBrains. Anyway, I should, yes. Right, stop making stupid jokes, Hadi. So here I have a class person, right, and this person, for example, has a name, a string, and then it has, for example, telephones or emails. And this is, for example, list of string, right? And then, if I'm in my nice little code over here and I say val p equals person, blah, blah, and then blah, blah, and I do p copy, what that's going to do, what is it going to do? It's going to copy the values, right? So this is a good way of, for example, doing something like if you are doing immutable data classes and you want to, everything is immutable, you can't change the value, how do you kind of basically copy or create, every time you want to change something, what do you have to do? You have to, what? Copy it, right? And then drill down and just change that specific value, which can be painful, right? Especially if I'm forced to essentially kind of like, change just a value, so I have to, and the constructor has multiple parameters, I have to pass in lists and all of these things just because I want to change a field. So one of the things that Arrow also provides is these optic ideas. And what this optic thing essentially does, it's have you ever heard of it's like a design thing that's called like don't call, the Hollywood principle, don't call me, I'll call you. You've heard of that? Yes? So that's got nothing to do with what I'm saying. I don't know why I remembered that. But there is another pattern which is like, don't, I can't remember the name, but it's like, if I have a class and that class has another class, I shouldn't be calling the members of that class. Huh? Yeah, the law of Demeter, right? There you go. So this is kind of like, yes, screw Demeter and his law. So essentially what optics does is, I don't actually use this, so I've not really used it in production at all, but I did want to show it to you. And what it does is essentially, using code generation, it allows you to decorate your classes, any data class that you provide with this annotation optics. It essentially allows you to drill in to the individual values, right, of that class. Okay, so when you're passing in constructors as well, when you're initializing something, you can actually initialize and just change a single property. Now, what I've shown you so far are a bunch of things with Arrow. I'm going to with this last thing that I'm going to show you, I'll move away from arrow, but this is also something that you may be interested in. And this is the idea of higher. This is the. Is that a bee? Oh, don't worry. Just let it. Yeah. Okay. Oh, I won't worry about the bee. So you all know what generics are, right? Yes. I'm not going to get into the theory of these because I don't know it. But think of a higher kind of types as a generics over generics. Okay? Kind of. Take a look at this code, right? Now, don't get scared. It is kind of scary, but don't get scared. Remember, scary is only what we do not know or understand yet, right? Like these, like bees, yes. So here I have a user repository, okay? Now generally what you can do is, you would all do like get all, and you could say, for instance, that this returns a list of users, right? And that's absolutely fine. But what if I want to, for example, not return a list of users? Let's say that I'm doing Rx. You're all familiar with Rx Java, and you want to return an observable, right? You want to return an observable. I don't have Rx here, I'm just using the observable. Imagine that there's an observable. And I want to return an observable of a list of users, or whatever, right? The problem is that as soon as I do that, what am I doing? I'm taking my code, and I'm locking it in to Rx Java, right? You know, like we've launched coroutines, yes? Yeah? Are you migrating to coroutines? Well, technically, you shouldn't really need to unless you really need to, right? Not just because there's a new shiny thing, you're going to migrate to it, you know? Heaven forbid that we just use new technologies because we're curious and we want to learn about them, right? And there's no real business reason. But we're developers. We would never do it unless there's a business reason, right? Right? But let's say that you do want to migrate from Rx Java to something else. What happens? I got to go through my code and use IntelliJ IDEA with the structural search and replace, and basically replace all of those Rx's with something else. But then that also forces me what? To basically change all of the APIs, because Rx no longer has subscribe and all of these things. Now imagine if for a second you could abstract even that away. Right? You could abstract the way that you want to use an observable. Today I want to use observable, tomorrow maybe I want to use coroutines or what have you. So this is where this higher kind of types come in, right? Which is essentially what this is saying is that I'm abstracting away the actual container that this is going to be using, right? So this is kind of like, as I said, it's like a generic of a generic. Now here's the implementation of this generic. So forget that applicative errors crap and all of that over there, and let's focus on this. What I'm saying is that I'm getting all users. Now, I'm getting all the users, so users can potentially be nullable. So I'm going to say from nullable, which is basically a way that allows me to check if something is nullable. And then if it is nullable, I call fold, which does something if it's success and does something if it's failure. So if it's failure, I say it raises an error, an exception. If it's not a failure, if it's successful, it returns an it. But nothing over here has anything to do with the actual implementation of whether I'm using observables or a sync or what have you. Nothing. It is, I'm just saying that I have some data. If it is successful, return it. If it is a failure, then do something else, right? Raise an exception. Now, where is this raise error coming and this just coming from? This is actually coming from this class applicative error. And what the applicative error is an extension to applicative. And what applicative is essentially the idea of it's a type class that essentially knows how to handle, similar to what we saw with functor, how to handle cases when there is a success and when there is a error in the case of applicative error. So I'm using the class delegation to say that this is delegated to applicative error. Right? So now I can have this raise error and this just. And still, nothing, absolutely nothing to do with observables. Now, at some point in my code, I want to actually use this. So how do I use this? Well, let's say that I have a dependency injection, hand roll dependency injection, and I'm going to create a repository, and I'm going to call it in-memory repository, right? Now this async is a type that's being passed in because in this case I'm using an asynchronous model, okay? So what I do is here, this is, I do init model and I do single K. What is single K? Single K, so Arrow has support for a whole bunch of different libraries, right? It has support for observable, it has support for different data types like flowable, monads, IOs, etc. Sorry, not monads, IOs, etc. And it allows you to call, initialize your higher kind of types with these different helpers. So in this case, what I'm saying is that single K is initialized with type async, and then what that essentially does is give me back an implementation of this repository, in-memory repository, that is implemented using observable, right? How does it do that? You basically put your code in the context of this module run, the run function, and notice that now repo get all users fix is part of the things that I get from the observable library, from RxJava, right? So Arrow in this case is providing a facade over these, exposing these APIs. If I wanted to tomorrow replace observable with something else, essentially all I would have to do is change how I initialize my module. And this is kind of like the higher kind of types. The main idea behind this. It's like taking the abstraction when we talked about having functions as the primitive building blocks that you can abstract on. This is taking it one step higher and saying now I can even abstract on essentially the types that I'm returning, right? And independently of what type I'm returning, I can do certain operations on it and then decide at the last minute what actual type I'm going to use, much like you kind of do in generics. Now, the flip side of that is what I was saying to you, that you can be the judge of this yourself. When you look at that, obviously, if it's completely unknown to you, that looks scary, right? And if you start to look at something like that, which is, you know, your code is full of these generics of generics of generics of generics, it kind of gets scary. Which then leads us to, I don't know if you've heard of, you know what Keep is? Keep is the Kotlin evolution enhancement process. It's basically a bunch of pull requests on GitHub that people propose on how the language evolves. There's a one that's called Keep 87, which is from the people behind Arrow with the idea of adding type classes and higher kind of types to Kotlin, which would simplify substantially the syntax that you see here. Okay? So that is the idea behind these higher kind of types. Again, this is something that I haven't actually used as such. I've been learning about it. One last thing I did show you that I haven't showed you is this construct over here. And this is also going to be simplified in a sense. And now the word monad comes, right? We've now got the monad. So take a look at this. This is essentially a block of 3 functions, okay? And it's saying toInt, toInt, toInt. Those are the 3 things that I'm trying to do here, right? And I'm going to take those and I'm going to sum the results of those, right? I'm going to say A plus B plus C. The problem is that these are independent in their way. Each function is independent. Like I can't change the result of saying, okay, get the result there, and if it's use a fold, if it's successful, do this. If it's not successful, do that. Because they're independent between them, but they are dependent in that for me to achieve the last result, I need all 3 to execute. Now, you say, why do you need all of this crap? Well, I don't, because I could say, if 2 to int doesn't throw an exception, then do this. If 3 to int doesn't throw an exception, and if 5 to int doesn't throw an exception, then sum the result and have this nested if statement. But if you start to look at the code like that, what happens? You start to have a whole bunch of code in your function that has nothing really to do with the intent of what you're trying to do and has more to do with error handling, right? All of those nested ifs, all of those whens are about error handling. The idea behind this, which is basically copied from languages like Haskell or even F#, where it's it's way more pleasant to the eye in terms of syntax because it's symbols that are built in, is the idea of bind, right? And what this is saying is that inside this block, I am going to do these operations. Only in the case that each of these operations is successful, then will I execute the code that is here. If it is not successful, then I will short circuit out of this block. So when I run this, if one of these fails, it will short circuit out. If it doesn't, it will present you with the actual value, right? You can see the little symbol here because under the covers they're using coroutines to do this. Okay? So this is the exact same syntax as this. It's the exact same thing, just a different syntax. And they're going to, in the next version, they're talking about even simplifying it a little bit more. Because yes, this is ugly. 4-try extensions, binding you can live with, but this try, 4-try, all of these does make it code a little bit ugly. So if I run this, you can see that I basically get the result of 11 and 12. Now if I take, for example, this and I say blah, 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 and I run this, you see that the result is essentially 11 because this one didn't execute. It essentially short-circuited out. And this is... you might have also heard of this if any of you have done F#. There's a great guy called Scott, I can't pronounce his last name, that talks a lot about F#, and he coined, I don't know if he's actually coined the term, but he calls it railway error handling, right? Because if you think about it, you've got your railways, and you know that at the railways there's junctions, right? So it's about, if everything is the happy path, I just continue. If there is an error in any of my function calls, what I do is I escape through the junctions, and I essentially short circuit out, if you look at it like that from a railway perspective. Okay, and with that, we're done with Arrow. Any questions?
Why not just use big try-catch?
Why not just use a big try-catch? Because, well, first of all, that is assuming that you want to continue to do your try-catches. Second of all, not everything is going to throw an exception, right? There are cases where it's not even about an error, it's about a return type. Let's say that, for example, if it's empty, I want to do something else. Let's say that I'm using validated, and if it's not empty, if it's valid, I want to do something if not. So it's not always about being able to do it as a big try-catch. Yes, louder a little bit, please.
So, your code swallow error. Your code swallow error. So user probably expect get sum of 3 numbers, but she sum of 2 numbers, but he didn't understand it, and
so you're saying that the user is expecting the sum of 2 numbers if one fails?
Yeah, first number, blah, blah.
Blah, blah.
For example.
Yeah, but then it won't run. What you saw is not, you didn't see the sum of 2 numbers. What you saw is actually only one of them working. So now you won't see an output. You see? Nothing happens. Right? It was just that I had two sample codes, just to show you that it was basically the same syntax. Okay? Okay, so, yes.
Okay, you have previously shown us fault that works and it handles an error. Is it possible to handle an error in this case, because swallowing error generally doesn't work, because error means that we have to handle it somehow usually?
Yes, of course. So the question is, can I actually, well, you've heard, but if you haven't, is can I handle swallow errors? So are you saying that you don't have like a big try-catch exception around your... but what you can do is you can essentially call, if you look at this, right, if we go over here and do val r equals, right, let's take a look at what r is. It's 12, okay? But if we do an A, what is R? It's failure, number format exception, right? So what does that mean? That on R, I can do, on R, I should be able to do get or else or any of the other functions that we've seen with arrow. Okay? Okay, so I promise you that this is going to be, you said as long as it's less than 1 hour, we're okay. Oh, you're okay? Are you okay for me to continue? Okay. Because you came all this way for an hour, it just is not worth it, right? So let's, I'll try and keep it to less than half an hour. Okay. So next, right. So here's a couple of things that you can do as well when you're talking about functions, right? Because one of the things that, like we've been talking about functions as using functions as primitive building blocks, okay? So I have functions and I can pass functions around and I can use lambdas and blah, blah, blah and all of these different things. But what happens if I want to, for instance, combine functions? What happens if I've got one function that I've written, another function that I've written, and I want to combine these? Well, obviously I could create another function that contains the two functions and then call them and do all of this. But again, it goes back to why do I have to write a whole bunch of other code in order to do this? Right? I could use a lambda to do this and call those two functions, but again, it's not the greatest way. So, well, it's not the most efficient way. So that's where we have the idea of composition, right? So here what you can do is essentially compose functions. And composition is essentially, you know, you all know maths, that, right? I got a function that I compose with another function, right? So what rule needs to hold for that to happen? That the output type of one function is equivalent to the input type of another function. As long as I have that, in principle, I should be able to compose these functions. So here, for instance, I have a lambda, and this could very well be a function as well. It doesn't need to be a lambda, it could be an actual name function. So here I have a lambda which is called source, and here I have a lambda which is called all lines, right? Now let's say that I have another one that is called find matches, which is doing some regular expressions on that. How can I compose these functions in different ways? So arrow also provides you with this compose function, which is essentially this infix. It's a function called an infix notation. So I'm here saying here like find matches, compose that with all lines, compose that with source. And I've got these small little different functions, and I'm composing them to create other functions that are combining the results. Input of one with the output of the other, right? And then you have like, you know, compose source and then do all lines and then find matches. And all of these, if you actually drill down to them, they're very simple, right? They're just basically higher order functions, which in this case is actually returning functions as opposed to, well, this is actually taking functions and returning functions as a result, right? Now, I think arrow implements this for functions up to like, I don't know what, 1, 2, 3, 4, 5, whatever number of parameters. Generally, you know, if you have functions that have more than 4, 5, or 6 parameters, composing them is not your biggest issue, right? You need to refactor that. Another concept that you may be familiar with, or you may have heard of, is curry. How many of you know what curry is? Curry. So Haskell Curry got a name. It's after the guy called Haskell Curry. And he's dead, by the way. Anyway, so curry, basically what it does, if in Haskell, every function is a function that only takes one parameter. So when you see a function in Haskell that takes 4 parameters, it's not actually taking 4 parameters. It is a function that takes 1 parameter, and then the result of that is another function that takes 1 parameter, and the result of that is another function that takes 1 parameter, and so on. Right? Every function in Haskell by default is curried. In Kotlin, that is not the case, and in many languages is not the case. But you can actually curry a function. So what does that mean? Well, here I have a function called sum that takes an int x and a y, and it takes 2 parameters. If I do sum curried, what is that going to give me? It's not going to give me a result, it's going to give me a function that takes a single parameter, right? So here, it's giving me a function that gives me a single parameter, and then on that function I can call it with a single parameter, okay? So if I run this, you're not going to get anything, because I'm not, it says sum is called and sum finishes, right? If I execute this, print line the result of this, then you actually see the result, right? Which is going to be 5. Okay? Now, why is this useful? It's not. Like, in itself, in that aspect, it is not. It's just a characteristic that is available in Haskell. But this enables another idea, right? And to understand this is we need to take a step back and think about a little bit object-oriented programming. Now, you all know object-oriented programming, and you all are familiar with the concept of dependency injection, right? Yes? Where I basically have a fancy way of saying that I'm passing in parameters in a constructor, right? So I'm passing in a parameter in a constructor, I'm passing in a type in a constructor, I'm passing in an instance of the class in the constructor, and then that class is doing the functionality. And instead of tightly binding to a specific implementation, I'm passing in, and then usually I wire that up all with what? With something like Coin or Dagger or whatever it is, dependency injection framework of the month. Sorry, IOC container of the month. So, which apparently this month is IOC containers are out of fashion. So if you're using them, stop. So what happens is that if you think about this in the functional perspective, I don't have a class, I don't have a dependency, right? What am I passing in? Right? I mean, if you take a look at, for instance, let's take a look at this pattern over here, right? A strategy pattern, right? Here's a typical implementation of the strategy pattern in an object-oriented model, right? I have a quick sort, then I have an interface sort algorithm, then I have quick sort, then I have bubble sort, right? If you actually look at the majority of the implementations of the strategy pattern, most of them, all they're doing is actually changing behavior. And yet we're writing all of this code to only change the behavior of a single function or what have you, right? So why constantly do this? Why not just, if my function is using some strategy, why not pass in that strategy? We do. It's called higher order functions. We pass in some functions as other functions. The problem with this is I don't want to constantly be passing functions to functions to functions to functions around. This is a problem. So that's where partial function application comes in. And the idea behind partial function application is that I essentially initialize a function with a certain set of parameters. And then I get back a function that I can call, right? So it's kind of like, if you think about it, it's kind of like doing dependency injection at a functional level, in a way. Right? So here when I'm doing sum partially, what I'm doing is partially1 is essentially a function that is part of the standard, part of the arrow. And this is like, when you're around here, as I said, no, like a partial function application is not your issue. Okay? So what partially1 is essentially saying, take a function that has a single parameter, assign that, initialize that parameter to a value. In this case, I'm saying 2, and then basically do sum partial 3. So this is giving me back what? It's giving me back an actual function, right? If I were to do print line sum partial, this is what? This is going to give me back a function, right? Notice that it's giving me back a function that takes a single parameter, okay? And then what I'm doing is now I've got this function. So you think about a function where you are reading from a repository. And you've got this function that reads from a repository, a user, and then that repository can be in memory or an actual database, right? In your code, you can have a partial function application of that function which initializes to database. In your test, you can use the actual full definition of the function that passes in a test in memory database or what have you. Right? It is essentially the same idea. And that's where partial function application, partially applied functions are useful. Right. One thing that I promised to show you is something around inlining. Sorry, I said at some point, I said that lambdas are different to anonymous functions in Kotlin. And in order to show you that, I want to talk a little bit about something that we have in Kotlin, which is called inlining. Okay? Are you all familiar with inlining? Right? Anyone not familiar with inlining? Okay, then we can completely skip it, right? No, you see, there you go. So inlining, but essentially what it does is a fancy way of saying copy-paste, right? So every time I call a function, instead of invoking that function and the consequent stack trace and all of the associated things with it, what it's doing is taking that code, copying and pasting it inside the place where I call it, okay? So in Kotlin, generally, the rule of thumb is that you only inline higher order functions with one exception. You generally only inline higher order functions because inlining functions that aren't higher order, generally the optimization gain that you have there is not significant over what the JVM potentially can provide you. So, but there is another case where you can do inlining, which is to obtain reified generics, right? So that you get some information at runtime. So here you can see that I've got an inline function, and it's giving me a warning why. If I remove this, this is absolutely okay, right? So it's saying, okay, you're inlining this because this is a higher order function, right? Now, the problem with inlining is that I cannot actually do anything with that function other than invoke it, right? Because it's inlining, there is no object to store an instance of that function. There's nothing. It's basically a copy-paste. And there are times, for instance, where you want to have a higher order function where you have, for instance, one parameter that is inlined and another parameter that is not inlined, because you want to hold the reference to that, right? And that's where you can use something like no inline. So if you ever see that, that allows you to see that this is no inline. Now, if you actually go back to what we saw here sorry, you see that there's another one which is called cross inline. Anybody knows what that is? Yes. Go ahead. Well, you raised your hand. Oh, you just were saying you know what it is. Okay, don't worry. Yeah, I'll explain it. Yeah. So to non-local returns, which goes to the whole concept of local returns and non-local returns, which goes to the whole concept of what am I doing here. So here is an example of, oh God, I hate this thing. There you go. Okay, so here I have a function. Here I don't have anything. I love this. Live inlining, it means Hadi, do it live. I'm like, oh God. Okay, so here I have a function which is, for example, do something, right? And then I say val numbers equals 1 to 100, and then numbers for each if it is divisible by 5, if it is divisible by 5, then 0, return, right? Print line, hello, it's me. Adele fans, anyone? Right, so do something, okay? If I execute this, what is the output of that? What are you going to see on the screen? Nothing. Why? Because the return. Why? Why? And? Why? Why? Well, because you know, you read in the documentation of Kotlin that lambdas.
Yeah, because that code just generally has been put there without any modification.
Why? Because for each is in line, right? Nobody said the word in line. They kept saying lambdas. You did? I'm sorry. I'll give you a T-shirt. Here, no. So yeah, but you know, and for many people that's not intuitive actually. But the reason is because it's essentially, you know, it's doing a copy pasting. So that goes to what does cross inline mean? That means that I cannot return. It does not allow local returns. So actually, sorry, to do a local return, what you can do is return it for each. Now it will return, right? So I can now actually see, hello, it's me, right? That's how you do local returns. So cross inline is saying that you're not allowed non-local returns, right? I said that right? Right, okay. Good. So a lot of times when you see a lot of the functions in Arrow, many of them are around cross inline. That's what that means. Okay? Inlining also, obviously, when you're talking about functions, well, it's great because it allows certain levels of optimizations. But there's other issues with functions. One of the great things about functions is that recursion is beautiful, right? Recursion is beautiful because it is a very easy way to express your intent. You write something recursively and it's very easy to understand. Here, everybody knows what this does. It's Fibonacci, right? And you don't, I can call this, you know, I can call this Manolo, right? I can call this Manolo. And you know what it does, right? You know what Manolo is? It's a name in Spain. It's Manuel, you know, you've heard of Manuel? Yeah, you laugh, but here's the thing. Before I joined JetBrains, I used to do consulting, right? And yeah, I was very depressed. And anyway, so what happened is that I went to this company in Spain, and there was a function there that was called fecha Manolo, right? And I said to them, what is fecha Manolo? And they said, well, so fecha in Spanish means date. So I said, what's fecha Manolo? They said, that's a date for Manolo. I'm like, what do you mean? It's like, that's a function that Manolo wrote because he wants the date in a specific format. I said, but there's 2 Manolos here. And they go, no, one of them is called Manu, the other one is called Manolo, right? And I said, so what happens if they want to change it? He goes, well, fecha Manolo too. Right? So that's what it goes. This is a true story. Like when I say that we suck at naming, it's true. So Fibonacci recursive, anyway, going back to what we're saying, Fibonacci recursive is very easy to understand. The problem with Fibonacci recursive is that if I do Fibonacci, go down here and do Fibonacci recursive, and I write 10, it's great. It runs, it's fast, it's wonderful. If I write 40, it runs, it's fast, it's okay. And if I write 50, it doesn't run. It runs, but it will take a long, long time to complete. Okay? It takes a long time to complete. Now, if I were to do that with Fibonacci iterative, that is instant. Yeah? And if I add 500, that is also instant. Yeah? But if you look at Fibonacci iterative, it is not easy to understand. It goes back to what we first saw, right? Now I got to do all of that mental mapping in my head. There are mutable variables. I got to figure out what it's doing. Can we get the best of both worlds? Well, languages, again, like Haskell, for instance, if you assure that the function is pure, what does it mean? That there are no side effects. It means if I execute it 1 or 1,000,000 times, I'm always going to get the same result. If I can do that, I can basically memorize the result, right? Which is called memoization of functions. In Kotlin, we do not have that. But it's not that difficult to implement, and in fact, Arrow has something similar. Well, it has something similar to that. But here's a very bad, not production code idea of the idea behind Fibonacci memoized, right? And yes, this does have side effects. Yes, I know. But the idea here is that essentially what I'm doing, I'm keeping this pattern of the actual recursive version of Fibonacci. However, I'm essentially memoizing the result, right? So this is what you call referential transparency, which is essentially I can pull out that function, replace it with a lookup table, and it will be the exact same behavior. It's pure, it's referentially transparent. If I were to run this, what is the actual speed, right? So if I run 500 on iterative, you see that it's immediate. If I run Fibonacci memoized on 500, it's going to essentially be immediate as well, right? So, if you have built-in support for memoization, and you combine that with pure functions, brilliant. You can now start to use things like recursion. And in fact, it provides you a lot of optimizations. And Arrow has a bunch of things built in. So there's a type class called eval, which allows you to do not only lazy initialization, but also remembering. Essentially kind of like the property delegated by lazy that you have in Kotlin, pretty much the same kind of behavior. And last but not least, talking about recursion and optimization, This is also available in Kotlin, which is tailrec, which essentially says that if a function is tail recursive, then if you add the tailrec modifier to it, what it will do essentially is replace that with a while loop, okay, under the covers. So factorial by default is not tail recursive, right? Because factorial is actually calling a sum before it's calling the function itself, right? A tail recursive function is a function that the last call is the call to itself. So you can take that tail recursive, non-factorial value, sorry, it's doing a multiplication. You can do the take the non-tail recursive function, convert it into tail recursion, which here essentially I'm passing in an accumulator, and then that will allow the optimization, okay? If you add something like tailrec over here to the initial one, it's going to tell you that this is actually not tail recursive, so it's really not going to have any effect, okay? So that basically wraps up everything to do with functional programming. We'll do a small segue, which is around, how many of you have ever created DSLs with Kotlin? Right, so when you go home today, you're just going to all create DSLs. So I'm going to do like a 10-minute, 15-minute thing around DSLs, if you're okay with it. Are you okay with it? Okay, cool. Let me grab a water. Any questions around all of this? No? Excellent. Can I what? Can we build a for loop with a tailrec?
Functional languages have no variables at all. So, for example, in Clojure, when you want to build loop, you use recur function which calls out a function. Can you build a loop in Kotlin using tailrec? So there are no formal variables, and it is a loop.
To be honest, I don't know. Max, do you know?
Can you imagine? Well, let's try.
Well, I'm not going to try it now, but we can try. We'll try it and get back to you. Give us an email.
Okay, thank you.
No, go ahead, Max.
I have a question too. There should be a catch, right? I mean, memorizing all the functions has its cost.
Yeah, the size.
Which is size of a memory.
Yeah.
I think you should say that.
Okay. I left that for you to say. Yeah. Yes, very good point. It does have a memory cost associated to it. Okay, so DSLs, let's do some live DSLing. So let's create a live DSL. Okay, so is everyone familiar with DSL? Yes? Do you know what DSL stands for? DSL means domain-specific language, right? Which essentially means a language that is specific to a particular domain. Do you like how I explain things? I basically take the words and I just turn them around, and then it sounds like I know my shit. So domain-specific languages is the idea that I can make languages that are specific to a certain domain. I just said that. So how many of you are familiar with the concept of DDD, domain-driven design? Right? Eric Evans, he wrote a book about ubiquitous languages, which is basically aligning the domain, like let's say I'm in the health industry, and the code that I write, it would be great if that code were to use a single language which was very, very close to the actual domain that I am trying to implement, right? So to give you an example, let's say that I'm doing an implementation of invoices, right? And I say, look, apply tax. You know, I wouldn't create a function that's called calculate percentage and then say, well, I can call it calculate percentage because I can then apply it to anything, including tax. I would create functions that are more specific to trying to describe exactly the domain problem that I'm solving. Now, this is very limited in what you can do in terms of languages because, you know, domain-specific languages usually end up being external in that you have to bring this external tool in where you can write this fluent kind of syntax to be descriptive and combine that with your other language, which is your main programming languages. There's also the aspect of internal DSLs, which are languages using the same language that you're using to create nice-looking DSLs. To give you an example, right? So let's say, for instance, let's say I'm like, this is, and I want to be clear, like there's many ways you can create DSLs, right? So for instance, I could create a DSL which is an HTML, the next version of HTML, right, that I can use. First of all, I do not recommend that you do that because it's already done. It's called Markdown. So just stick to Markdown. But the point is that that is one type of DSL. Another one is actually small DSLs that I want to use in my code. They could be around configuration. They could be around describing tax rules. They could be around anything. Okay, so I'm going to give you an example of how to do, for instance, something like a configuration. Okay, so let's say that I have a class here that is called class configuration, and it's like a server configuration, and I'm going to have a var, a host string, and then a var port int. Okay, and then I'm going to have var security, and that's going to be, for instance, a security class, and then I'm going to have a class security. And this is going to have is secure Boolean, and that's it. Right? That is my security. Okay? Okay, is secure. Now, if I want to initialize this, what could I do? I could do val c is configuration, and then do here, you know, I can initialize that. I'm actually going to write it with default values. Security. And then here, I'm going to do false, okay? So now I do C host equals localhost, C port equals 9090, and C security dot is secure equals true. Now, you don't usually do this in Kotlin, right? You could do something like with C, and then take these people over here, move them up, and then take this C and select it. Okay? Wait, I'm getting to it. Okay? So now you could do it like that, or you could even do something like this. Yeah? Just do apply, and then here do host equals blah, blah, blah. Okay? That's one way. But I don't want to even do that, right? Because if I have, like with security, I can even do is secure. Okay, thank you. So, now here it's nice, val c equals configuration. Okay, now let's take a look at this. Let's concentrate on that one. Let's forget about the apply, let's concentrate on that one. What is this? This is noise with. Why can't I just essentially get rid of this, right? And get rid of that, and do something like that. This is much nicer, and I can say configuration, do something like that. Okay? That's what I want to get to, right? That's my goal here. So how can I do this? Well, let's think about it. What is this? This is configuration. What is this? This is curly braces, but this could actually be a lambda, right? This could actually be a lambda. So let's go ahead and create a function of configuration. Configuration, and this configuration, what is it going to take? Okay, well, we know what it's going to return. It's going to have to return a configuration, right? That's easy. Okay, now what is it going to take? Well, what is it taking? Well, it's taking a lambda. So okay, so it's got to be a lambda. Let's make this beautiful. It's a lambda. But what else? What is it doing? It's setting properties of host. Now, if you're not familiar with Kotlin, we have something called extension functions, right? You've all used them, yeah? They're beautiful. They're the best. So what you want to do is, if an extension function is a function, if I have higher order functions, why don't I combine both things? And that's one thing that is unique in Kotlin, which is the concept of lambdas with receivers, which is higher order functions that take extension functions as opposed to regular functions. So if I say that this is taking a configuration, right? And it's returning a unit, this essentially allows me to now have access to the properties of configuration, right? It's allowing me to do that. Yeah, you following me? Because what it's done is saying this lambda now is not just a regular lambda, it is a lambda that has access to the instance of the type it's extending, which is configuration, right? So I can do the same thing again, except I can't really because this is a function. But I don't want to create a function here. What is that? What is that? That is like an object. And what am I trying to do? I'm trying to invoke an object as a function. Right? I don't want to do, can I do that? Well, actually you can. In Kotlin you can do that as well. So, to do. Next time. Now, that's actually very simple. You just basically do configuration equals apply, blah, blah, blah. Now, let's take a look at this. Okay, so if I have a class, okay, let's say for instance I have a class Q, okay? And what I'm essentially trying to do here with this security, because remember security is an object, I'm going to say val, you know, no, that's not, do you know why you should never name variables foo? Because if you want to create a class called Q, it doesn't look good. That's actually also a real story, and I'm going to tell you it because it's funny. At least when I was there, it was funny. Two friends of mine, they used to do pair speaking. So one of them was the coding monkey, and the other one was the speaker, right? And the speaker was German, and he was explaining MSMQ, Microsoft Messaging Queue. And Richard's sitting down writing code, and he says, Richard, create a queue. So he says foo queue, right? And he creates a queue called foo queue. And Christian's on stage, not realizing, he's like, so now we have a foo queue, and blah, blah, blah. And with this foo queue, and he says, Richard, we're going to put messages from one queue to another. Can you create another queue? What does Richard do? He creates a foo queue too. And that's why you should never name things foo. But going back to foo, what I want to do is I want to invoke this. How can I invoke this? I want to essentially do something like that. You can do that, and the best part about Kotlin is you don't even need to know Kotlin. You just need to know IntelliJ. So you just press Alt-Enter, and it does it for you, okay? So essentially what I'm doing is I'm implementing the operator invoke, and with that, I can now invoke an instance. So if I can do it there, I can do the same thing here. So I can do Alt-Enter, create invoke. Right? Now, coming back to this, what is it that I want to invoke again here? What is it that I'm passing in? Again, I'm passing in what? A class. I want to access the properties, therefore I need to pass in an extension function to security, right? So I pass an extension function to security, and voila, I have my DSL. Okay? If you feel compelled at any time to clap, it's absolutely fine. I'll accept it. But no, I'm joking. Have you ever seen that chart of, you must have seen it, there's this chart of like what is awesome to what is okay, and based on different nationalities and cultures. Like, you know, awesome is everything for people from the US, or like, you know, the US, everything is awesome, right? For the people from like England, you know, awesome is just something that's just really, really awesome, right? For many people from, let's say Russia, right? The awesome is like, okay. So I know where I am, it's okay. Right. Now, obviously this is an issue, right? Because what I'm doing here is, first of all, I don't like this, having to initialize values, right? This sucks. And second of all, this is var, and I told you that we shouldn't do var. So how do I solve this? Well, I can actually remove all of this and get rid of the port and get rid of this over here, and just let's simplify this so that we don't focus too much. Let's just do it on this one, okay, over here. So now I can't set this, right? I can't set this because this is, first of all, there's no initial value. Second of all, it's actually val, right? So what I can actually do here is now create essentially a configuration builder, right? Yeah. So I could create a configuration builder class here that basically has a function that's called build that basically returns configuration, right? And this is going to be return configuration of host and port. So here, for instance, I would have var host and var port equals 0, right? And then what I can do here is instead of passing a configuration, I would pass a configuration builder and then use apply and essentially now get my mutable types, etc. Okay? Awesome. And let's just, for people that are allergic to something, we'll call this awesome configuration, not a builder. Okay, there you go. Now, Java's gone, right? And you basically follow the same model over and over again, and you can essentially create your DSLs. We've gone a little bit too far, so I won't dive into how to do collections and that, but there is other things that you can do. I would also recommend that you look at, I'll leave as an exercise, we have this annotation called DSL marker, which essentially allows you to limit the scope of what certain things you can do, because if you start to do other blocks here, there is potentially that I could reuse host here, for instance, right? Like if I were to have that security, I could potentially use host again here. And you don't want to do that, so you want to restrict the scope, and for that you can actually create an annotation and then annotate that with annotation DSL marker. But I'll leave that as an exercise for all you to do. Okay, I'm expecting it tomorrow at 9 o'clock in the morning. Right, with that, sorry I ran over late. I hope you at least enjoy it. Thank you very much.